Hey guys, so in the last video I mentioned an issue I was having with physics. I got a lot of useful suggestions from you, the viewers, and thank you. I actually was able to resolve the issue because of that. So here is the helicopter from the previous video, and it's actually set to interpolate, and the renderers are not doing any kind of interpolation, and it's actually smooth. There's no jitter on the ground, and there's no jitter on the helicopter itself, and it actually turns correctly at the proper speed. So it turns out the issue was in the code. I was doing something wrong. It was actually Angel Garcia, also known as Eddie, from Eddie's Vehicle Physics Kit, that actually found the issue. The problem was that I was actually modifying the transforms local rotation inside the update function instead of doing it by adjusting the rigid body's rotation using the move rotation function, which would apply all the physics stuff and take everything in consideration correctly, and it had to be done in physics update. So I was actually doing it in the update, and because I had the rigid body's interpolation set to interpolate, it meant that transforms rotation was actually set by the physics using the calculations of the physics system itself. And I was also modifying it myself inside the update, so the two were conflicting. It basically had to be done in one place and had to be done properly, had to be done in physics. And that's exactly what Angel suggested, and it worked. So thank you, you fixed the problem. Well, moving on. In the previous video I also mentioned that I wanted to try and move the water with the waves and whatnot going up and down, rocking the ship. Unfortunately, I was not able to use Unity's Water 4 for that. Reason being is it actually modifies the vertices inside a shader rather than on the software side, which meant that as far as physics is concerned, the mesh was not actually changing. So there were no modifications and no new forces to apply to the ship. There was nothing I could do. Fortunately, since I am taking a full physics-based approach, I was able to resolve the issue differently. I ended up simply moving the object's center of mass instead. So here, when I hit play, you may notice that the center of mass is actually moving slightly forward, sideways, and so on, and the ship ends up rocking side to side and a little bit forward into the back, which is more subtle, of course. And I also figured it would be a good idea to make it accelerate. As the ship is moving faster, the rocking becomes more noticeable. So the effect is nice, and I didn't have to do any kind of hacks with the water and modifications of meshes and physics and whatnot. Looks quite nice. After I got that done, I figured it would be even more interesting if the sails were physics-based as well, if I was using cloth physics for the sails, because right now they are quite static and they're not moving when the ship is moving. I actually had it done at one point and it looked great-ish, and then I hit Ctrl S to save and Unity just crashed and I lost everything. It was good times. So now I actually have to redo all of it, which is kind of good because now you get to see what I've done. So here's what the original mesh looks like for the sails. It's actually double-sided in the sense that all the geometry is duplicated, and I've actually done that via code. The original sails that come from 3 Studio Max are one-sided. I just created them only on one side. And here you can see it's 484 vertices, but I need it to be double-sided, and there's actually 2 ways of doing this, and they both have advantages and disadvantages. So here, let me show you. I'm going to start with the original sails mesh, which is one-sided. And I'm going to change the shader to be double-sided. Now the easiest way of actually doing that is simply specifying call off in the shader itself. What essentially this will do is it'll draw geometry from the front and from the back. But there's a downside to doing it this way. The lighting is all wrong and the shadows are messed up. Now the lighting being wrong is, well, you can live with it, I suppose. Especially if the material is like semi-transparent like the sails. But the shadows being incorrect on the reverse side, yeah, that's a big issue for me anyways. You see what happens here? So the shadow is actually bleeding right through the geometry. Anyway, another way of resolving this issue is actually duplicating the geometry in the actual mesh itself. And you can actually do this in a modeling software that you're using, or in my case, since I'm a developer, I just wrote a quick script to do it. So all I have to do is just select the sails, the original sails. You notice it's 728 triangles, and just export it as a double-sided OBJ. And all this does inside is just it duplicates the vertices, flips the normals, and saves both the original and the duplicated vertices as one mesh. So here's that one mesh. If you actually look inside, you will notice that the number of triangles has effectively doubled, but it is actually proper on both sides. Now if I was to actually use this mesh instead of the original, ignore the fact that UVs jumped. OBJs don't support secondary UV coordinates, so I have to have only one set. But yeah, you can actually see that it is correctly lit on both sides and everything looks proper, and the shadow does not bleed through. But anyhow, how do you actually convert this render into a cloth render? Well, it's actually fairly easy. Let me add a new game object. I'm going to call it cloth. And here I'm going to attach a cloth render, which automatically adds the interactive cloth as well. For the mesh, I'm going to specify my sail mesh, the double-sided one. I'm going to disable this object. And for the material, I'm going to specify the sails, the light sails. Now, for some reason, the symbol is gone, which makes little sense to me, because it's the same exact mesh and same exact material. So, go figure. But I'll delve into that in a bit. Right now, if I actually hit play, this is what's going to happen. Yeah. Doesn't look very pretty, does it? Now, the reason for that is because we're using a double-sided mesh. So it seems there's some Z fighting going on because of floating point differences between the points. At least that would be my guess. So let's change the sails to be single-sided instead. And hit play again. Now there's no Z fighting, everything looks correct, and the symbol is actually here. Go figure. Now another problem. You see how the ship is moving smoothly but the cloth is not? Yeah. I've yet to figure out a reason to fix, a way to fix that either. But anyway, one problem at a time. First, how do you actually keep the sails up and prevent them from falling down? Well, it's actually quite easy. What I need to do is actually add colliders. So, say for example a box collider. I'm going to move it up here. I'm going to give it a small size. And it'll be fairly long. And I will also position it like so. Now you will notice that it overlaps the sails ever so slightly, and it's actually good. This is what you need to do in order to keep the cloth up. So here on the cloth there's a field called attach colliders. I'm going to change this to 1 and specify that child collider right here. Now if I hit play, the sail will remain in place. Now it's still going to be jittery, it's still going to be one-sided, but at least it doesn't fall down anymore. Easiest way to create flags this way. Well, let me pause the video a bit and actually set up all the colliders. So here's what it looks like when it's finished. And you can actually see that I have colliders on every point that is supposed to be attached. And of course now if I hit play, it will stay in place, but there's going to be a lot of Z fighting going on. And it's going to look generally ugly. And so the question is how to fix that ugliness. Well, one obvious solution would be to switch the cloth back to single-sided version instead. But of course, this will mean that it's only visible from one side. Although it obviously does look much better when you are able to see them. It's affected by the wind nicely and everything. But yeah, single-sided, just ain't gonna cut it. And of course there's still a matter of this jitter that happens with the sails, because the sails don't seem to follow the rigid body's smooth or transform interpolation. Yeah. And so that's where I'm at right now. I figure I can actually try some other things in the future, like adding some bones to the model in 3D Studio Max and actually moving the bones programmatically in Unity. So the sails would actually be moved using bones rather than cloth physics. It would give me the same smooth effect, but without the weirdness of the physics system. We'll see what happens and if I actually manage to do it for the next video. Of course, if you actually do have any suggestions, or if you've encountered such issues in the past and figured out how to resolve them, just let me know in the comments below. Thanks for watching.